Experimenting with lasers. A team of people within this humble physics lab at the University of Otago are punching well above their weight internationally. Recently, PhD student Ryan Thomas ran an experiment to prove or disprove the Pauli exclusion principle. The principle states that if you cool lasers down to an extremely low temperature, you can trap particles and then smash them into each other.
And so what we do is basically we trap the laser beams in a horizontal, we call it a waveguide, basically a horizontal laser beam that's oriented horizontally, so the atoms can't move up or sideways.
He says from there it's all about controlling the matter.
And then we also further trap it using two beams that come up vertically, so now that they're basically trapped in 3 dimensions, and by steering the vertical beams, we can move them around in this waveguide. And then what we do is we take a single cloud and we split it apart, and then we accelerate them together and let go and watch what happens.
Associate Professor Niels Kiergaard says while the experiments are tightly controlled and follow the Pauli principle, he admits there are random elements at play.
We do actually, for some conditions, see some violation. And this is not because this Pauli principle breaks down, but because we get some higher order processes. So because we have this rather pristine system and we see deviations from this no sidestepping rule, where you get this dark band and you get some population into this dark band, we can use this as a very sensitive measure of tracking these higher order processes.
Thomas says it is not like creating nuclear energy, and there are no more hazards than in any other laboratories using lasers and electricity. Kiergaard is pleased his group and their Little Hadron Collider are among the top academics studying ultra-cold physics anywhere in the world. Daryl Baser, 39, Dunedin News.